In the last video, we discussed about how do we find out the confidence interval for population mean when the population standard deviation sigma is given. But sometimes the population standard deviation sigma will not be given to you, okay? And also the sample size are small. In that case, we need to estimate the confidence interval for population mean using the sample standard deviation, okay? And we use slightly different distribution. We don't use inverse norm, and we don't do g alpha half like that. We rather use inverse t in the calculator, and we use t alpha half. Instead of g distribution, we use t distribution, okay? So the sample size, if the sample size is greater than 30, then the g distribution and the t distribution are almost the same. But if the sample size is small, and if this standard deviation, population standard deviation sigma is not given, then we should be estimated by using this sample standard deviation. Instead of sigma, we'll be using s, and then use the t distribution. Let us talk briefly what is the t distribution. T distribution is bell-shaped symmetric about mean, bell-shaped curve which is symmetric about mean, median and mode equal to 0 and never touches axis. It is similar, okay, but it is not a unique curve. It depends on the degrees of freedom, meaning the sample size. Variance is little greater than 1 because it is more flat. The distribution is family of curves based on the concept of degrees of freedom. Degrees of freedom is which is related to the sample size. If the sample size is n, then the degrees of freedom is n minus 1. 1 less than the sample size will be the degrees of freedom. And when you use the t table or inverse t, you will need the degrees of freedom there, okay? We'll talk about that. The degrees of freedom are the number of values that are free to vary under the sample statistic after a sample statistic has been computed, and they tell the researcher which specific curve to use when a distribution consists of family of curves. We denote it by d dot f dot, okay, and has one less value than the sample size n. Here is an example, okay. Pick a set of numbers that have a mean or average 10. Some sets of numbers you might pick will be this: 9, 10, 11, or 8, 10, 12, or 5, 10, 15. All of these samples have sample mean 10, right? Once you have chosen the first two numbers in the set, the third one is fixed because you want to make the average 10. If you pick 9 and 11, the third one must be 10 to make a to get the average 10, right? In other words, you cannot choose the third item. You cannot choose third item in the set. It is already fixed. It will be fixed, right? The only numbers that are free to vary are the first two. You can pick 9 plus 10 or 5 plus 15, but once you made that decision, you must choose a particular number that will give you mean you are looking for. So degrees of freedom for a set of 3 number is 2, because you are free to pick first two, but after you pick first two, the third one must be fixed, right? So you have just two choices there. That is, you are free to choose first two. It can be 9, 10 or 8, 9, 11 or 8, 10 or 5, 10 like that. But the third one must be fixed if you want to make the sample mean 10, okay? That's why the degrees of freedom in this case will be the sample size, the total sample size minus 1. As the sample size increases, the t distribution approaches to the normal distribution. So what is the formula to find out the confidence interval for mean when sigma is not known, not given, or sample size is less than 30? Is the 1 minus alpha confidence interval. Exactly the same way. X bar minus, instead of g alpha half, we have t alpha half here, and instead of sigma we have s. That is the only different thing. All other terms are the same, okay? And the extra thing you need is n minus 1, sample size minus 1 degrees of freedom. So similar to the g values and inverse g value, we use secant, verse and inverse t. But some of your calculator do not have inverse t. TI-83 calculator does not have inverse t. In that case, we will have to use the table, okay? So I will show you both method. And also there is a direct way to find out the confidence interval for population mean when population standard deviation is not given. Exactly do the same thing, stat test, but instead of G interval we use T interval because the sigma is not given. Okay, we use T interval, and in the T interval you'll have to use this enter the sample size and everything. Okay, we'll see some examples here. If the data is given, then you will have to choose the, instead of stat you will have to choose data. All other things are similar. Okay, instead of sigma you will have to enter SX, that is the sample standard deviation. Okay, let us do this example. A random sample of 10 children found that n is 10, right? N is 10 children found that their average growth for the first year is 9.8 inch. Is this average, is the population average or sample average? This is a sample average because it says a sample of 10 children has average 9.8, that is x bar is 9.8. Assume that the variable is normally distributed. All these must be normally distributed. Okay, otherwise this method do not work. And sample standard deviation is also given. S is given 0.96. Find the 95% confidence interval. How do I find the 95% confidence interval? So the 95% is in the middle, right? 0.95. So the outside area is 0.05, right? 0.05 is the outside area. Now to divide that into two pieces, divide by 2 is 0.025. So this value is 0.025. This one is 0.025 as well. Now we need to find, instead of G we have T alpha half. T alpha half. Okay, to find out T alpha half, your calculator has inverse T. TI 84 and above have TI, those calculators have inverse T, but your TI 83 do not have inverse T. Okay, so I will show you how to find out if your calculator do not have inverse T. First of all, let us see how we find out if your calculator has inverse T. How do I find out T alpha half? Okay, so and here what you do is you go to the second and then verse and then go to inverse T. Okay, number 4, inverse T, hit enter, and what is the area left? By the way, this is negative T alpha half. Okay, I will do that. 0.025. What is the degrees of freedom? Sample size is 10, so the degrees of freedom is 9, one less than the sample size, so it will be 9, and then hit enter, paste, and then do negative 2.2621. okay, this is what you got, negative 2.262. So if you round up to 3 decimal place, negative 2.262. See, inverse T alpha half, negative 2.262. So this is negative 1 because 0 is in the middle. This is positive. So basically positive T alpha half is positive 2. So T alpha half will be 2.262. That's what you do. Okay, if your calculator do not have inverse T, what you need to do is you need to go to the table. I have a table copied here in the next page, but for the table you will need confidence interval. So 95% confidence interval. Okay, let us go that to the table. So 95% confidence interval. What is the degrees of freedom? Degrees of freedom is 9, right? Go to the 9, degrees of freedom is 9, and 95% confidence interval is 2.262. That's what I got from the table. Instead of doing inverse T, you can use the table if you want to. That is perfectly fine. So pick the confidence interval and go down, and then degrees of freedom is 9. So go up. That is the value. Okay, that's how we find out the value using the table. Okay, so then what I do is now I have everything that I need for the formula. X bar is given, T alpha half, we found that. S is given 0.96 over root n. N is 10, right? So if you do that, you will get these values. So this is how you find out by hand. But how do I find out this using calculator? I think your calculator can find out directly. Even if you have TI 83, you can find out directly this confidence interval. How? Go to the stat and then test, and then go to the T interval. Scroll down to the T interval. Okay, number 8 is the T interval. And then do you have data or stat? We have the statistic, right? What is X bar? Our X bar is, let me find out that X bar is 9.8. So that is 9.8 is the X bar. What is S sub X? 0.96. That is, what is S sub X means? It is the sample standard deviation. We got a 0.96. n is 10, right? In this case n is 10, and the confidence level of confidence is 95, right? 0.95, and you hit calculate. If you do that, you will get 9.11 through 10.45. I got 10.45 here because I took some decimal places here. I rounded up some decimal places. But if you do not round up, then this is what you will get. If you do not round up to 2 decimal places or different decimal places, it depends on how many decimal places you round up, okay? And then you will get slightly different values, but otherwise it is okay. 10.45, 10.48, and then 9.11. That's what we get. Okay, we got exactly the same thing. So this is using the t interval directly, and this t interval can be used for your TI-83 calculator as well. All right, let us do another problem. Let us do example number 2. Okay. A recent survey of 8 randomly selected social networking sites has a mean of 13.1. What is X bar? Is 13.1. What is N? Is 8. And the standard deviation is 4.1. This is the sample standard deviation. S is 4.1, and you want to find the 95% confidence interval. So 95% confidence interval means in the middle there is 95%. Right, 0.95. So outside is 0.05, and you want to divide that by into 2 pieces, right? So 2 is 0.025. What is the degrees of freedom? Degrees of freedom is sample size minus 1, that is 7. Okay, now I want to find out T alpha half negative and T alpha half positive, that boundary. Okay, so this is 0.025, degrees of freedom is 7. So I want to use calculator for this. So inverse, let me clear this. Go to second verse and then inverse t. And left area is 0.025, and the degrees of freedom is 7 actually. 7, okay? And then paste it. If you do that, you will get negative 2.365. So you will get this negative t alpha half, because negative 2. Is that 365? Let me make sure. 365, you're right. So that is 365. That will be T alpha half. The positive will be 2.365. Now we use the formula. So X bar minus T alpha half S over root N, right? Times S over root N. Similarly, X bar plus T alpha half times S over root N. This is what you get. So what is X bar is 13.1, 13.1, comma, T alpha half is minus 2.365, 365 times S is 4.1 over root under 8, N is 8, right? That's why. And then do the same thing with plus. X bar, that is 13.1, okay? So 13.1 plus 2.365 times S is 4.1. So that will be 4.1 times 4.1 over root under 8. If you do that, let's see what you get for the left bound and the right bound, okay? So for the left bound, I'm doing 13.1, okay? And then minus 2.365 times 4.1 divided by square root of 8. That's what I get. If you hit enter, you will get 9.67 2. So that is 9.672 comma, and the other one is same thing with plus sign. What I will do is I will just second and then enter, will copy everything. Now I want to move that cursor to the minus and then make it plus, okay? If you do that, that is 16.528. So that is 16.528. That's what you do. Okay, this is by doing by hand, but we can do the same thing using calculator directly. How do I do that? go to the stat, and then test, and then go down to t interval, not t test, t interval. Okay, we do t interval, hit enter, and then we have a statistic. We don't have data here. Statistic x bar is, how much is x bar? X bar is 13.1, right? So 13.1. And then what is sx? Sx is 4.1. S is sx. So sample standard deviation is sx here. So 4.1. And then n is 8, right? The sample size is 8. And then what is the degrees of freedom? Degrees of freedom is 90. Sorry, not the degrees of freedom. Degrees of confidence level. So 95% again. So that is the same 95%, and hit calculate. You get 9.672 through 16.528. You get exactly the same answer. Okay, guys. So for example 3, you will have to enter the data in your calculator and then do exactly the same thing. Okay, let me show you how to do that. So what I want to do first is I want to enter the data in your calculator. So how do I do that? Stat and edit. So since I have L1 has data already, I want to enter that in L2. Okay, how do I do that? Is 5460, hit enter. 5900, hit enter. 6090, hit enter. And then 6310, hit enter. 7160, hit enter. 8440, hit enter. And 9930, hit enter. So I enter the data in L2. Okay, don't forget that. Okay, now what you do, I have to go to the t interval. Go to stat and then calc and then t interval there. Okay, t interval, hit enter. Do you have data or stat? We have the data right now. Okay, so we entered the data already. Where did we enter the data? It is in L2, not in L1. So L1 has the old data, so I don't want to use that. I want to use L2. So second and then 2 will take that L2 there. Frequency, it is not frequency there, so that's why I take this frequency 1. And what is 99% confidence interval? So go down to the 99 and then 99% confidence interval, make it 9, and then go down and then hit enter. You get 4785 through 4785 through 9297.9. Okay, 4785 through 9297.9. So 4785 through 9297.9 is the 99% confidence interval that the population mean falls between those two numbers. Okay, so you can do it this by hand. To do this by hand, you need to find out x bar and then s. You need to find out that from the data. Okay, and then use the formula again, the same formula. We'll use that. Okay, guys, thank you. That's all for section 7.3.